introduce that time big data analytics. First workshop to various scientists and like that. That was also our beginning. Later we have done lot of work in big data analytics. Some 3 to 4 PhDs we could able to produce, where we got a good number of papers. Now in the same way, we now just started what we can do in this, not particularly Sanskrit, in general. We do have tokenization already, but we want to do something differently. Hence, we have been exploring two ways. One is joining with one project with IIT Mandi, that is one thing. Second thing that we started with the Hindi, because our students who are at NIT Warangal, they are a little bit proficient in that. Hence, we started developing some different kind of tokenization. Hence, that particular part of work which we will run from our system, that will be shown in maybe my lecture is up to 4:15. Maybe after 15-20 minutes I will show it. And I'm not much informed that what kind of gathering will be there. Hence, in general, I thought that we can introduce this basic thing. Perhaps you have given already the research point of view. No? Yes, fine. Maybe 15 minutes తర్వాత అతనితో కనెక్ట్ చేస్తే అక్కడి నుంచి రన్ చేసి చూపిస్తాం. అప్పుడు అక్కడ and even now I was talking with your Vice Chancellor. The very purpose of initiating these workshops are how to take this Sanskrit to the masses. Hence, since now the AI is becoming, can we have something called SEI, Sanskrit for AI, like AI for Agri and all these things. Hence, as today has coined that word, SEI, SAI, Sanskrit for Agri. That is a good initiative. Sometimes when it comes from the people like him, the man of letters, definitely it will go to a larger extent. Yes, that's a good idea. Hence, we'll be soon we'll think of. I said that there's always danger if we take certain things to the masses. Hence, we should use the technology very cautiously. There are limitations for the machine learning, perhaps already you might have seen. Hence, when we are running these algorithms, it will look at what are the things that are frequently happening, and it will try to catch it, and from that it will infer something knowledge, and then it will try to repeat it, create it. Hence, if your goal is quite simple, just you want to repeat the history, well, the machine learning is one of the good option. Hence, do you want to write another some Sanskrit slokas or one kavya you want to build in the same lines, maybe in one kind of chando, because maybe different kinds of things. Hence, you want to imitate Kalidasu or someone else, maybe it can catch some patterns and it may try to generate it. That is one thing we can think of. Second thing, the summarization and making the people proficient in one language, these are all quite simple things. Simple in the sense with little effort we can get it. That is another point. But the danger is if something is not frequently occurred, infrequently, rarely occurring, but those are all quite important, where only the drashta can see in depth of it, what it really means. It may not be quite frequently occurring as many other words or topics or subtopics, something like that, but that require a deep analysis. But how to get that? That is again a difficult part. If that is not properly handled, then sometimes injustice may happen. That is the only one danger that what we have. Though there is some little research that is going on in generalizing it, always there are pitfalls for generalization. These are all certain things. I think these a few points which I am beginning at the now telling at the beginning may not be clear to all the people, but these are certain comments which I have just now had a talk with our Vice Chancellor. Coming back, as I told, my second part will start with one of my students' work that is currently running, where he has developed his own tokenization, which we are proving that better than the current state of art. That we are running on the natural languages or the low resource languages. That I will show it. But meantime, let me go through this. Hence, these buzzwords, this AI, ML, neural networks, and deep learning, perhaps a little bit you are aware of it. That the goal of machine learning is making the machines to learn. Right. Yeah, thank you. We want to make the machines to learn like humans. The way you learned, the same way machines would like to be learned. Is it possible? Yes, to some extent. In some topics which we have formulated within this machine learning, perhaps now I came to know that there are MSc computer science students. They might have studied under the titles something called supervised learning, where you will have some, given the training data, it will try to catch the patterns and thereby it will learn it. But when it sees some object which is unseen in the training data, how it behaves. It may be performing better on the training data samples, but when it goes out of the distribution, then how it behaves, that we have to be very sure. That's why we have the topics which we talk under the generalization. That generalization, we have to control it to some extent. We have to do it. And second thing is, out of distribution is another concept, which is also to be dealt with cautiously, where we have done one of the good research work recently. One girl for her 5.5 years work, she has done good three IEEE transaction papers, where our work was focusing on fake news detection. There we have handled this out of distribution to some extent. Hence, these two are again the problems. Hence, I am telling these points to some scholars. Whenever you need some work, since we have done something at NIT Warangal, we are quite interested to collaborate with you and do it. That's the point. Hence, now, when our goal is making the machines to learn like humans, yes, we can train it, and by looking at the training data, it will try to get certain patterns out of it, and it behaves as if it has knowledge. But remember, when a machine is recognizing you, it is not seeing you like I see you. It will take your picture and compare with the pictures that it has it in the database. Hence, I can recognize a madam, and I can, okay, she can recognize me, I can recognize you. Hence, the human recognition is different. Whereas, if I say finally my system is recognizing her, it is not recognizing the way I am doing it. What it is taking her photo and comparing with this and retrieve it. Hence, that is not quite natural. Hence it has these limitations, the said limitations. However, still we are trying, because we should not leave the hope, we are trying it. Now within this there are multiple schools of thought. One such is when humans are doing quite differently from the way the machines. Hence why not we imitate the brain? Hence they introduced the neural network approach. Hence this neural network approach, again almost nearly 70, 80 years, more than 80 years, 70 years old, but quite recently, because of good amount of computing power and good amount of data, it has come to the fore. Now there are good number of applications with the title called deep learning, where we can have different hidden layers within that neural network. That's the thing. Now there are so many subfields, certain things which you are now people are aware of it, this chat GPT and all, perhaps the students are using it, but these things which I can consider under this deep learning, and we are focusing more on this large language models today. And this let me skip, which is relevant to how to distinguish the traditional programming between the machine learning model, because there we give one program and the data, thereby you will get the answer, which we call output, whereas here we give the both output and data and we get the model. In the sense that model is embodiment of patterns. Hence patterns are to be extracted from the data. Hence now what do you mean by pattern? How do we extract the patterns from the data? That is the crucial point. Hence if you look at how this now Tirupati, if you go in a flight, or if you look at from some place to the other place, then you will come to know there is a hilly area, there is something water area, okay. Hence you are connecting the pattern like this. Oh, hilly area is over. What do you mean by hill is over? Or the forest is over? Now we entered into Tirupati. Oh, forest consists of trees. Don't we have trees in this campus? We have trees in this campus. Then why you are not calling it as forest? Here the predominant objects are the buildings. There the predominant objects are trees. Hence these predominant objects, the buildings are used for this academic purpose. Hence this is something like an academic institution. Hence you are not calling this as forest. In the forest, predominant objects are trees. There also you have snakes, rocks and all, but we ignore them. We look at the predominant objects. Hence thereby you are labeling some pattern, and thereby you will say that one pattern is over, another pattern is started. Hence always our remembrance will be how it moves from one source to destination, or from one point to another point, what are different patterns within that. Hence to say that this forest is a pattern, what you have looked at? You have looked at the predominant objects and what is the similarity among them. If the predominant objects are trees, we are not bothering about whether it is a neem tree or any other kind of tree, banyan tree or that, it is just a tree. Hence that similarity we catch it. Hence in loose terms, pattern is a collection of similar objects. Hence that similarity you will try to catch it. Hence when you are tomorrow, when you want the mission to catch some pattern in some of your data, it will search for such a pattern, means such a set of similar things inside. Hence, do you have such things in your data? That's what I have started at the beginning, the first 2-3 minutes of my lecture. What I have said is, if something is not frequently occurring, if many such objects are not seen, every moment it is different from the previous, then where from the pattern it catches? Hence, the pitfall in this machine learning is, entire knowledge is the interpretation of patterns. The pattern extraction is possible only if you have lot of similarity among the objects with signs, whatever the object may be. It can be the images, it can be the words, or whatever it may be. Hence, we have to understand this, because when we move from one domain to another domain, always we will be hopeful, oh, we are unable to solve in our domain. Suddenly this new thing will come and it will help us, it will solve all our problems. Always we want something, Allahuddin, some magic thing we want. There is no magic in everywhere. Hence you should know the limitations of this. Hence if you have patterns, yes, those patterns can be repeated again. Hence are you interested to repeat that? Suppose some story is written earlier. Do you want to have similar stories? 100 stories are to be written, because it may be laborious task, time-taking task for a human being, where a system can generate. By tomorrow morning it can create another 100 page or 500 page story. Do you want it? Then you come here. That's one point. Hence, like this, it will take the data, it will try to build the models. The model which is nothing but embodiment of patterns. And again, the many people who enter into the machine learning, they misunderstand that model means algorithm. No, model is not an algorithm. Algorithm can't be called as model. Algorithm you are executing on the data, and that algorithm will extract patterns. The patterns will formulate the model. For example, those who are aware of it, decision tree is a model we call. How a decision tree is formulated? It has extracted patterns. There may be something like this, and there is another pattern like this. When there is something common part, when you keep that, then you are getting something graph. And therefore, for me, I will see the tree is full of paths from the root node to any leaf node. Hence, for me, when I look at that, the tree is just consisting of several paths. Since the several paths are enjoying some common portion, it is so formulated a graph. Further, the graph has a unique path from the root to every node, hence it is called a tree. Hence here what happened? The algorithm has extracted patterns. The patterns, since they are sharing something common portion, that patterns, they are formulated some apparent structure. The structure is visible to you. Hence patterns are being extracted. They formed a coherent shape. The shape is apparent to you. The shape is looking like a tree, hence you have called it as a tree. Since it is deciding your class, it is called decision tree. But will it be all right? Always happens. May not be. Patterns may be extracted. It may be forming a cohesive structure, but it may not be apparent to you, as you have seen in the decision tree. Since it is not apparent to you, you can't say there is no model, there is a model. It may not be sometimes cohesive, but still patterns may be extracted. Hence, the whole model is nothing but embodiment of patterns. Okay, this neural network which would like to simulate the human brain, we have initially started with MP kind, and we have certain input features because have very limited time. there will be certain features, and when it comes to the features, how to extract features, who will give the features, that's one point, feature extraction. In the machine learning, that is one of the main goal. How do you, whether you give the features or your algorithm is going to take it, the feature extraction. And the features what you have extracted, are they necessary, are they sufficient? Okay. Hence this feature engineering is one of the important and the tough work. But sometimes now people are thinking that this deep learning, particularly the CNN, and these are all helping you to extract the features quite easily. But the person who knows the machine learning kind of feature engineering, and we compare with this, always we have to compare these two, and then we can figure out whether properly the features are extracted or not. That's why both these schools one should teach. The feature engineering that is happening in the machine learning and feature engineering, that is a separate step, whereas in the deep learning it is the part of the neural network learning. These two things we have to be very careful. Hence, once we fix the features, each object will have the values of the features. That's all. Hence, once you have features f1, f2, fn, and when it comes to the object 1, under each feature there will be a value. Hence, these values of the features, what we call them as data. And from that data only we try to extract patterns. Hence, since the machine cannot see the objects directly, the only way that what we can give to the machine is the data. Whereas we are looking at, if I go to a garden, I can look at the flowers directly, I can extract, I can say what are the different features of a flower, how a flower is distinct from the leaf. Whereas my system cannot see that. Therefore, I have to extract the features, I have to give explicitly the values of the features for each flower, and then thereby it has to get some understanding over the flowers. That's the way that we deal with these missions. Okay. Hence, that's what here what we have mentioned here, this x1, x2, xn, these are all the features. Thereby that given these features, then that particular object, as I said, for each object there will be values of the features, and that object, whether it is this or that, 0 or 1, or one of these several classes, is it rows or something different classes, that what we can do, that is what the classification, most of the activities which we do in the supervised learning. Hence, I thought of covering what are the limitations of this initial model, and then how we made it learning. What do you really mean by learning? When there is no adjustment of the weights, there is no learning at all. That again we have to understand it. Because certain fundamental words we have to learn. Our students generally say, yes sir, I have built the learning algorithm. Where is learning happening? You don't have weights, you are not adjusting the weights, you are not at all operating it. Then how learning will take place? Hence, then we explicitly, the teachers who have come from the traditional background, we teach what really the learning means, how do you adjust these weights. And of course, this perceptron, when we move from the single layer to the multi-layer, what kind of problems that we can generalize it, and the celebrated backpropagation algorithm, and what kind of activation functions that we have to use. This is what I have said. The feature extraction is a separate step in the machine learning, whereas it becomes the part and parcel of the deep learning. And certain tasks, that's something like classification which we can do. As I was referring that the feature extraction that is being done deep learning by CNN, and how the CNN works, then the limitation of CNNs, why we go, and particularly since you deal with the text, how I can handle the text with CNN and certain things which we have developed, and thereby how your ChatGPT is working. If I give some collection of words, how it will predict the next word, or the given word, how it will predict the next neighboring words, and then what's the problem with the CNN, what are its limitations, why we have to go for RNN, and how we can deal with this. Then LSTM we will come, because the problem with again RNN, it will have only short term, long term dependencies cannot be caught. Therefore we have to go for the LSTM, how we put this forget gate, all these things. This is what we thought. Thereby we will go again for this transformers, the sequence to sequence models. Why we need this? Now using these attention models, now we are building this the transformers attention models only being used in LLM. This I thought of introducing for 1.5 hours or so, more than that, depending upon the gathering. Then I thought of showing our work, what we are doing using LLM, which we have developed using the Hindi tokenization, which we have run just one day earlier on some Sanskrit text also. Yeah. Yeah, that will be run now. That he will be showing. Is ready? Yeah. Now give him, yeah, the chance to present. Will it be projected? Yeah. Just look at it. If that's, if you like it, then we can collaborate on that contact. Yeah. Yeah. I start Pranit. Nada? Is it there? Yeah. Yeah. Pranit, you can present it now. Yeah. Yeah, that is. No, I Telugu rather.
Sir must have given an overview about how in the past how the past technologies have worked which related to the RL and LSTM, and mostly we'll now be focusing on how we can use the state-of-the-art method, that is transformers, and the heart of the transformer, that is multi-axis attention, how it is outperforming the current. So since we are dealing with the Sanskrit language, which, as we all know, that Sanskrit is often regarded as the mother of many Indo-European languages, and it has a profound influence on the linguistic as well as the culture and philosophical tradition of the South Asia. So I have been sharing one of the PPT. If I think it will be visible on your screen right now. So mostly in this particular thing, we will be yes. So mostly we would be dealing with now is Sanskrit automatically text summarization using the state-of-the-art NLP technique. Since we have already gone through why the Sanskrit is a since we all know that Sanskrit is a low resource and morphologically rich language, and uh, and it becomes quite a cumbersome process when it comes to go hand in hand with the state of the art methodology. So there is some pipeline while we are dealing with NLP projects. So I will first give you so before starting the pipeline, I would just like to give you certain challenges that are associated with this Sanskrit language. The first one is the morphological complexity that is associated with this language. The first one includes the inflection morphology, since you all must be aware of that. For example, not. For example, English has certain rules to follow. For example, subject, verb, and object. Subject, which is being followed by verb and then object. Whereas it is not the case when we look at the Hindi languages or the Sanskrit languages. For example, you can see over the it has been seen in the PPT as well. That it has given one Ram sees Sita, which has been translated into Sanskrit Ram Sita Pashyati. So this can be arranged into various forms. All these things convey the same basic meaning. Since since there is a change in the word order, but the overall basic meaning remains the same. So this also need to be handled while working with this Sanskrit language or the Hindi language. So since we all must be aware of that, ki Sanskrit language or Marathi language or Nepali language or Hindi language, they all mostly based on the Devanagari script. And the next challenges that are associated with the Sanskrit language is the semantic ambiguity. So let's suppose we have a particular word which is dharma, and dharma can be associated in different forms. For example, when we dharma can be related to religion, also duty, law, or virtue. It totally depends on the context in which we are using it. So these are the challenges that we need to look, and also the foremost thing is the resource scarcity. There is a limited digital corpora available on the online resources, open the resources, and also there is a lack of annotated text while working with any languages, particularly the low morphological language. So these are the certain challenges that we need to look before starting for any NLP work. So after this, I will start giving a brief overview pipeline about how an NLP pipeline works. How an NLP pipeline works. So there are certain stages, which there are total 5 stages, and this is not a universal pipeline. This is not a universal pipeline. This can work in a non-linear fashion as well. So first stage that always comes in each and every project that we are going to work upon is the data acquisition part. So in data acquisition part, whether it is the data which is present in the form of the table, in the form of the database, or we can use the various APIs or web scraping Twitter APIs we can use. And also sometimes when we talk about particular low morphological language, we are mostly, if we are having a data, then the size of the data is very less. Since we know that the deep learning model or the LLM model are the data hungry models. So as much as data you gather for these models, it will be tend to converge our model much better with better accuracy or on the other evaluation metric. So for this, we are going to apply some various data augmentation techniques on this less data. For example, when we look at the text data, the various data augmentation techniques that we can follow is we can replace with their synonyms. For example, while talking about running can be replaced with a jogging. So, and also one is back translation. Let's suppose I'm working on a Hindi data set. So in order to perform a back translation, what I did was Hindi data was first translated into English, and then English was translated back into Hindi. So in this process, the data has been augmented, as well as the semantic features are also being preserved, and also we are getting some new labels for the particular data. The next step which comes under this is the text preparation part. So within text preparation, there are various stages include. First of all, it includes the text cleaning, basic pre-processing, as well as advanced pre-processing. We will be looking into much detail in using the code. And next part, which sir has already explained you about, is the feature engineering part, and we will also be looking into it. And next is the modeling and the evaluation part, and next is the deployment phase. So since NLP domain works in various applications, so mostly we will be focusing on the text summarization and also the know-how of the sentiment analysis. So since if we talk about the text summarization, mostly the text summarization is basically classified into two types. So first one is abstractive and second one is extractive. So the main difference between abstractive and extractive is, so extractive is like taking phrases directly from the original text without any modification. For example, as you can see from the example which is shown below, the sun is a massive star and provides light and heat to the earth, which is 150 kilometers away. So similarly, this text has been shortened down into taking just the phrases directly from the original text without modifying it. So the earlier techniques that were used in this were TF, IDF, graph-based, and a bird sum and sentence transformer. And now, mostly at the current stage, we are mostly focusing on the abstractive summarization. In the abstractive summarization, we tend to generate the new sentences, and we are going to rephrase it as the original text. Okay, so the techniques which are used in this is LSTM and attention, and after that we have transformer-based model. For first, particularly, we have used the T5, which has been released by MT5, which has been released by the Google, and also we have fine-tuned our summarization model, which we are going to look into detail. So since now we are looking into the abstracted text summarization, this is the overall pipeline which is involved in this. First one is the text input, the Indic NLP tokenization. Then the fast stack embeddings, how we are going to give our tokens into the fast stack embedding, and these embeddings will be further used by our transform model, which is the MT5, and we are going to evaluate this using a Roche metric. So first stage, now we'll be going deeply into this first stage, which one is the data pre-processing part. So since Sanskrit and Hindi works on the Devanagari script, so I'd like to show you the script, how this it look like. So this script is started from 090 to 097F. So these are all the Unicode characteristics which are involved in a particular Devanagari script. So we need to make sure that while pre-processing our data, there should be a cleanup so that only the important information which is present in the text should be carried forward. And the stages which are included in this is we need to remove the unwanted characters. And also we need to use for example, it has also been shown using the example over here. Now I would like to show you some code which will depict you how the pre-processing part has been given in this. So first of all, here you can see imported certain libraries, which are the Python libraries, which are include the fasttext and the pandas and the numpy. So first of all, loading our data set, which is a movie reviews, which is released by the IIT Patna, which is in Hindi, of course. And this is how it look like. And the first thing that we have, the pre-process. Hello? Yes, sir. Is it visible now, sir? So first we have loaded our data set using the pandas library. After that, the first thing that while working in a text processing, the first stage that we have seen is cleaning up our text. So there are certain Unicode characteristics. For example, there are Unicode character related to the emotions. If you are working in a if you're working on a social media data, then when someone writes something, then they used to enter emojis also, some symbols also, some special character also. So we while training our model, these characters won't be of much use. So what we tend to do is, the first thing we are going to remove all those things which is of not much use to our data set. So first thing is, these are the various emoji patterns. For example, These are various Unicode characters. First, we are going to remove from our data set. This is how the data set is going to look like after removal of this emoji pattern. And the next part is with respect to, let's suppose if you are dealing with any social media data and also some sentimental data, then some sentimental data also includes some URLs as well as some username also, which is also of not much use, and also some extra spaces we need to make sure that we can truncate it. So, and also special character like hash symbols and curly braces and all that we need to make sure. And also the one more thing that we can see over here is, since I have shown you the Devanagari script spanning from 0900 to 097F, so this is a regex command, so which makes sure that all the character apart from this, which is lying in within this range, should be excluded. And also this is a danda. Danda is like a full stop in the Hindi language, also known as a phone viram. So this makes sure that any character which is not lying inside the range as well as the space should be removed, should be replaced. The first parameter in this is the string and the pattern and the text that we are working on. So this is how we are going to perform the text pre-processing part. Then this is how our data set from this is how our data set used to look like this, and now it has been changed to this, which is just like a simple Hindi text, which is going to be of much more use than the previous one. So after that, the next stage which is present in this is the, after data preprocessing, this is about the first stage. The second stage is about the tokenization. So what happens is, once the data preprocessing has been done, rather than feeding our text directly into our model, so first we tend to divide our text into various tokens. So this is just a random example in Sanskrit language, how this text is divided into various tokens. So either you can divide it into unigram, bigram, or depends on the usage. Depends on your references. For example, I have taken only a unigram for an instance. So the main division for each and every language, if you are talking about any particular library, whether it is Spacey or if you are talking about ChatGPT has their own tokenization scheme with the name of tick token or the byte pair encoding scheme. Here we are dividing on the basis of the space which is present within each and every word. As you can see, the above review has been split into this format. So once this tokenization, the second stage of tokenization is done, as we can see, this has been, whatever I'm showing is how it is working underneath the hood. Later on, I will show you within just using a single library function how it can be done. This is how the internal work architecture I'm showing you how it is done. So once this embedding generations are done, so once this tokens have been generated from the text input, now what we are going to do is we are going to map our tokens with respect to their corresponding token IDs. So what is a token IDs? So you can assume these token IDs as a kind of dictionary. Let's suppose you have a dictionary from A to Z letters. So each and every word which is present in the dictionary will be mapped to certain unique IDs. So similarly, the same thing works with respect to our tokenization scheme. So each and every tokens have their own unique ID. So what we are going to do is we are going to represent these tokens with their corresponding token IDs by mapping them. So once these token IDs have been matched, now we are going to use the pre-trained embeddings. For our example, we have used fast text pre-trained embeddings, which is in the dimension of 300. So as you can see, I have portrayed with the example also. For example, the cat chase the mouse is a text input. Now it has changed into a token. It has been divided into various tokens. Now these tokens have been mapped to various token IDs, and using the fast text embeddings, we are going to map these token IDs into their corresponding dimensions. And what do I mean? Mostly these are the pre-trained embeddings, and these are the static word vectors. So the main idea behind this is, I'll show you with respect to code. So once this token has been generated, this is the token has been generated for each and every reviews. As you can see from the code, for each and every reviews, we have generated the token. Now after that, we are going to look for the embedding generation for each and every
tokens that has been generated. For this, we have used a fast text library, which is representing each and every token in the 300 dimension vector. So let's suppose this is a Hindi word which is by the name of Chandar. It has been represented. These numbers represent something. These 300 dimensions have their own attributes, feature attributes. Yes, yes, sir. Yes, sir. Uh, Sir, it will take time, sir. Actually, it is on my. So mostly these tokenization has been. So shall I continue, sir? Yes. So while using our fast-text embedding, the main difference is these fast-text embeddings are the static embeddings, and we tend to make sure that these embeddings should also make sure the context in which we are using. Let's suppose there we have two instances sitting on a bank next to a river, and the second sentence is thinking about my empty bank account. So the first sentence and the second sentence, almost the word bank will going to represent the same contextual embedding, but the word in which the sentence in which they have been used is totally different. Because sitting on the bank next to a river, referring to a river bank, where the second one is referring to a bank account. But the embeddings which are generated by this fast text will be same only. So how to make sure this static word embeddings, how we can change into the contextualized word embedding, so that the semantic meanings as well as the contextual meaning is also being preserved. So there come the usage of our self-attention models. So as we can see, by using the self-attention architecture, we can make sure that static embeddings can be changed into the contextual word embeddings. So mostly, so shall I explain the overall architecture with how the self-attention mechanism works? If time permits. Okay. So this is all the internal architecture. If I have just a small code with respect to this, since we have all worked with the ChatGPT model. So I'm showing you the internal architecture, how the ChatGPT model have worked. So mostly the heart of every LLM is the transformer block, and within the transformer block, the engine is the multi-head self-attention. This is mostly, I'll explain you the overall architecture, how the ChatGPT is working underneath the hood. So first of all, we would be giving an input as a token embedding, as you can see from this code, which is of the dimension of the vocabulary size by the embedding dimensions, and as well as the position embeddings. Position embedding is like a making sure that the order of the particular sentence is also met. For example, the cat is sitting on the mat. Mat, the cat is sitting on. So all these two sentences have the same order, but they are rearranged. But the embeddings which are generated with respect to this will be same only. So how to make sure that the position are also being attached with the token embedding. So that's why we have added a position embedding to this. And after that, we have a dropout layer for this. As you can see, this architecture is much more similar to the original architecture. This is the actual GPT architecture. This is the token embeddings of the dimension of vocabulary size by the embedding dimension, and then the token size by the embedding dimension, which we are going to concatenate it. After that, we have the layer normalization. So mostly the layer normalization is going to change our mean to 0 and variance to 1. The main idea behind this is, and also it makes the training procedure stable by preventing the vanishing and the exploding gradient problem. And after that, we have the this is the overall architecture, how it is working. So I think that's it from my side regarding this. Thank you, sir.
informative talk. Sir spoke about Sanskrit text summarization, in which he has touched upon what are the basics of MLDL and what are their shortcomings, which has led them to build build a model for which has their own tokenization algorithm. And he also spoke about model in context, behavior of model in context of out of distribution. And his student presented a demo which shows summarization using Indic NLP in Hindi language, which is low resource and morphologically rich language. It is quite impressive, and also touched upon morphological context. He spoke about what are the complexities in summarization of Hindi language. So he touched upon syntactic flexibility, semantic ambiguity, resource scarcity, and also he touched upon the pipeline in his particular demo, wherein he says they have developed a tokenizer which basically uses, which is based on context, semantic and position based embedding. So thank you, sir. Thank you very much.
Thank you very much, ma'am, for your summarization of this session. And now I am requesting Professor Kadambani ma'am, please come on to the dais and felicitate our today's keynote speaker. Sir, please come on to the dais for felicitation. Shrikant. And I am requesting Janaki ma'am to please give a moment regarding CDAC related on behalf of CDAC. Thank you very much, ma'am. Kadambani ma'am, Janaki ma'am, and Sart. So now we will have a tea break for 10 minutes.